right, so what we're going to do now is we are going to look at transformations of exponential functions. So, looking at example 1, it says describe the transformation from the parent function f of x equals 2 to the x. So I'm going to pause a moment and I want you to try letter A. Look at what you see. The parent function is in fact 2 to the x. And all the transformations that we did before apply. Okay, everything we did before applies. So derive part A and part B. So think about left, right, up, down. Is there a stretch or a shrink? And any reflections? And just to help us in the future, let me pull this out. Not like it, but plugged in here. Hopefully that comes right back. Yay, beautiful. All right, is there anybody feeling confident and wants to share letter A? Taking a guess based on our knowledge of transformations. Yeah, Wyatt? Outstanding job. Okay, so guess what? If you replace x with x plus or minus a number, that's going to be your left, right, the opposite of what you think. And then on the outside, if you add or subtract a number, that's going to be your up, down. All right, having said that, in part B, h of x is 5 times 2 to the x plus 1 minus 9. So I see 3 transformations. I see 3 things on this one. All right, who would like to try and help us with this one? Anybody want to try? Becca, what do you think? Awesome. Down 9, left 1, and a stretch of 5. Okay, nice work. Okay, so what I want you to write sort of at the tippy top here is the parent functions are always going to be y equals b to the x. Nothing in front of it, nothing after it, and nothing else other than x. So what's going to happen, so now what we're going to do is we're just going to do, I think, four graphs, and we're just going to practice this, okay? And we're using a similar technique to what we did with square root functions, absolute value functions, and the x squared, the parabolas, the quadratic functions. Now we're going to apply them to exponential functions. So in example 2, it says we want to end up graphing f of x equals 4 times 1/2 to the x. What is the equation of the parent function? Well, the parent function is going to be y equals, my b value is 1/2, so it's going to be y equals 1/2 to the x. So what we're going to do is we're going to fill in a table with 5 key points to the parent function. In exponential functions, the domain is negative infinity to infinity, so that's why we do negative 2 to 2. Now we're doing this to the parent function. So if I take 1/2 and square it, that's 1/4. 1/2 to the first is 1/2. 1/2 to the 0 is 1. Now remember, when you take 1/2 to the -1, that flips the fraction and makes it 2 to the first. 1/2 to the -2 flips it and makes it 2 squared, which is 4. All right, describe the transformation. There's a 4 out front. So, and really, technically, that's a vertical stretch of 4. So now we're going to do this mapping notation. I didn't do anything to the x. There's nothing up with the x, up in the exponent with the x. But the vertical stretch, this is like, okay, do you see that I let the parent function be y equals 1/2 to the x? This is 4 times that y value. Like that's why I'm doing 4 times y. So let's go, I'm going to change colors here. And you're going to keep the x values the same, but you're going to multiply the parent function table y values by 4. Okay, that's all you're going to do. This says keep the x values and then take 4 times the y values. So that would be what? 16, 8, 4. What's 4 times 1/2? 2. And then 4 times 1/4. What's that? 1. Now, the only time that horizontal asymptote is going to move is with a shift up-down. Let's maybe write this note. Okay, your horizontal asymptote is y equals 0 unless there's a shift up-down. Nothing else changes the horizontal asymptote. Yeah. Oh, okay. Do you see here where we've used the mapping notation? We kept the x values, so these are why the x values are -2 to 2. Now we said we're taking each of these points and you're multiplying the y values by the 4. So that's where the 16 comes from. All right, so I'm going to draw a horizontal asymptote here. That's going to be at y equals 0. I can tell from my table that the y-intercept is 0, 4. Now, we can do one of two things here. We can either change the scale, or we can say, okay, -2, 16 is like way up there, and kind of eyeball it, because that's the only one off the grid. I'm okay with either. I'm going to leave it by 1s. But make sure you show that that exponential is getting closer and closer to the horizontal asymptote, but it doesn't touch it. So then my range is, in fact, 0 to infinity. Okay, the range, even though it goes positive infinity down to 0, interval notation is always written smaller value on the left, larger number on the right. I do see it's going from positive infinity and getting closer to 0, but that's not how we write interval notation. If I want to go back to the purple, my parent function, and pop this one on here, that was -2, 4, -1, 2, 0, 1. So then it's really, really quite cool. You can see the vertical stretch. I want to pause here a moment. Do you see that? The y-intercept was 0, 1, and on my final one, it's 0, 4. The y value is 4 times. the parent function y value. That's what a vertical stretch is. All right, so all transformations apply. Yeah. Yes, you remember yesterday when we graphed y equals 2 to the x and y equals 1/2 to the x. Remember that from yesterday? Well, the horizontal asymptote for all exponential functions, y equals a times b to the x, is going to be the x-axis. So, and the only time it's going to change is if I shift it up or down. No, if I had, like, if I look back up here to example 1, do you see how in part B, this one's been shifted down 9? My new horizontal asymptote would be y equals -9. That's what I mean. This one, what would be the horizontal asymptote on this one? It'd be y equals 5, because the whole thing's been shifted up 5. Yeah, that's the only time it's not going to be the x-axis, y equals 0. Yes, that's it. That's it. Good job. All right, so let's look at example 3. And this, unfortunately, went on to the next page, but for our iPads, that's no big deal. It says we want to graph f of x equals 2 to the x minus 1 power. What is the equation of the parent function? All right, anybody want to try this? What is the parent function? Yeah, Lilia? Good job. Okay, it's always y equals whatever the b value is to just an x. All right, fill in a table of the parent function. So that's -2 to 2. And I'm going to try to walk slowly and let you fill in your table. Okay, plug in the -2 to 2. So I like to start at the bottom of my table because I know how to do 2 to the 2 power. 2 to the 2 is 4. 2 to the 1 is 2. 2 to the 0 is 1. 2 to the -1, remember, is 1 over 2 to the first. 2 to the -2 is 1 over 2 squared, or 1/4. All right, now it says describe the transformations. Well, there's only one, right? It says f of x is 2 to the x minus 1. How is this graph being shifted? Davey? It's right 1. That's it. This is just right 1. So guess what? In my mapping notation, what that means, if I want to shift the graph right 1 unit, I would add 1 to each of the x values. So we're circling back to what we did in the previous unit. We just did it with absolute value, with square root, with x squareds. Now we're doing it again. So I'm going to look at my x values of the parent function. Okay, that's at -2 to 2. And I'm going to add 1 to each of those x values. So if I do that, that's -1, 0, 1, 2, 3. Nothing happened to my y values. They stay the same. Yeah. Do you see the parent function? This is -2, -1, 0, 1, 2. I'm moving right 1. So that means I take every x value and I add 1 to it. -2 plus 1 is -1. -1 plus -1 is 0. 0 plus 1 is 1, and so on. All right, so let's plot this. Now, moving right 1, did that impact my horizontal asymptote? No, right? The only time my horizontal asymptote is going to change is if I shift it up or down. Left, right doesn't do anything to the horizontal asymptote. So I'm going to go ahead and before I graph the points, I always plot the horizontal asymptote, and that is a requirement of your sketches. That's not like an optional thing. That's your boundary. Okay, that's the limiting boundary of your exponential function. So I have 3, 4, 2, 2, 1, 1, 0, 1/2, and -1, 1/4. So all that happened is we moved the graph right 1 unit. So the domain is -infinity to infinity. My range is still 0 to infinity. I would say 95% of the time, and I'm making that up, your y-intercept is in the table. That's where x is 0. It's where the graph crosses the y-axis. So my y-intercept is 0, 1/2. And we could graph the parent function, so let me change colors. The parent table was 2, 4, 1, 2, 0, 1. So then you can literally see the graph, my blue graph is to the right, or from the blue graph to the purple one is right 1 unit. Every single point has just been shifted right 1, right 1. Kind of cool to be able to see both of them together. All right, let's try the next one. Graph f of x equals 3 to the x plus 2 minus 4. All right, what is the parent function? Davy? Nice job. Y equals 3 to the x. All right, we want 5 key points. So for exponential, that'll start in a parent function of -2 to 2. All right, go ahead and plug those into 3 to the x. Get your table values. If you're a fast worker, describe the transformation. So 3 to the second power is 9. 3 to the first is 3. 3 to the 0 is 1. 3 to the -1 means 1/3. 3 to the -2 means 1 over 3 squared, or 1 over 9. Okay? All right, describe the transformations. There are 2. There are 2. Sydney, what do you think? Awesome. Wait, left 2.
Left 3 and down 4.
Down 4. There you go. There you go. Left 2, because it's the opposite with x, but the same on the outside. All right, who wants to try the mapping notation, that t of xy? If you want to move every x value left 2 and every y value down 4, what do you think we might do in the mapping notation? Keelan, what do you think?
X minus 3, y minus 4.
Awesome. There we go. There we go. All right, we're cooking. We're cooking now. All right, so here's what I want you to do. Take every x value. Take every x value that we did. This is why we write out the parent stuff, okay? It helps. So take every single one of them and subtract 2. That's your new x column. Take all the y values and subtract 4. Now, you might either need to do a calculator with the 2 fractions, or do your best with the fractions. I'll kind of explain what I do, but at least do those 3 whole number ones, and then subtract 4 from those. You should at least be able to do those 3 that will be whole numbers, or integer values. All right, your x values. Did you get -4, -3, -2, -1, 0? We got that? Okay. All right, then the y values, if I take 9 minus 4, that's 5. 3 minus 4 is -1. 1 minus 4 is -3. All right, now, if you do 1/3 minus 4, watch this, okay? I don't even have to touch my calculator. That's -3 2/3. Do you see that? I only took a third away from the -4. So that gave me -3 2/3. Then, if I do 1/9 minus 4, do you see that I'm only taking 1/9 away? So that's -3 8/9. It does not matter to me if you give me decimals. You know, if you want to do decimals and use your calculator, that's absolutely fine. Okay, this is our first time. This one's a down 4. Anybody want to attempt? What would be my horizontal asymptote now? Yeah, Ella? Good job. And we're going to write it as an equation, right? We're going to write it as y equals -4. Good, I can still see my y-intercept in my table. My domain is always -infinity to infinity. And before I do the range, I want to plot this. Go ahead and draw, here's your horizontal asymptote of y equals -4. I'm going to plot the points and then I'm going to do my range. I like to see the graph before I do my range. So 0, 5, 1, 2, 3, 4, 5, -1, -1, -2, -3, and then do you see the other two are just getting super close to that y is -4. So my range is -4 to infinity. Can anybody think of a transformation that might make our range change from that horizontal asymptote up? What kind of transformation might change it so that it isn't going up? Any ideas? Yeah, good job. A reflection over the x-axis, which is going to lead me to my next example. All right, questions on this one. The left, right, the up, down, my horizontal asymptote. Any questions? Anything you need to clarify in your mind?
Is the parent function always going to be, for the tables, always going to be -2?
Yes, for exponential functions, your parent function will always go -2 to 2 because the domain is all real numbers. All right, let's look at example 5. It says graph f of x equals. Now, do you notice there's a negative in front of the parenthesis? So it's not inside, so you don't stick it inside. So what is my parent function on this one? Becca? Good job. Y equals 3 to the power of x. So I think I may have not given us 2 tables. So let's put this one beside it. So we're going to do -2 to 2. So Keelan asked an outstanding question. In exponential functions, the parent function will always go -2 to 2 on the x column. So plug those in. 3 to the 2 is 9. 3 to the 1 is 3. 3 to the 0 is 1. Whoops. 3 to the -1 is 1/3. 3 to the -2 is 1/9. All right, so what's my transformation? There's only one here. Good job. There's a negative out front, so that's a reflection over the x-axis. So that means my mapping notation is x comma negative y. If I want to reflect over the x-axis, that means, do you see, like if it's up here at y is 3, down here it's y is negative 3. That's why it's a negative y. So nothing changed with my x values. And then all you're going to do is put a negative in front of your y values. My horizontal asymptote does not change with the reflection. Let me say that again. The horizontal asymptote does not change with the reflection. It only changes with an up-down shift. That's the only time the horizontal asymptote will change. So let's draw y equals 0. That's the x-axis. Then here's 2, negative 9. 1, negative 3. 0, negative 1. So notice, I'm going to fill in my range now. The range is going down to negative infinity. So I'm going to say the range is negative infinity to 0, but not touching the 0. All right, we are going to stop there. If you would like, example 6 and 7 are challenges. If you would like to take that on.